Welcome to our next class in a nutshell to help you get caught up should you miss class. This one is going to be about horizontal and vertical translations. Our entire first unit is about what we call transformations. So it's a way to take a function and turn it into a different but related function. Translations are some of the easiest transformations. So it's literally moving a function. Could be to the left, could be right, could be up, could be down, could be some combination of both. So we're not going to ask you to move it 30 degrees this way, but we might ask you to say move it horizontally and move it vertically, so it would work out to being the same thing. So how do we do that? Well, let's take a look at the function horribly sketched here, y equals x squared. I'll graph that here. So this is our familiar parabola. If we want to move it to the right, let's say we want to move it 5 units right. Well, the way to do that is to make this function, which is probably easier to think about it in the f of x. So as a function, we want whatever happened when this function equals 0 now to happen when x equals 5. So we can do that by transforming our function or replacing the x with x minus 5. Now, whatever happened when x equals 0 will happen when x equals 5. What used to happen when x equals 1 will now happen at x equals 6, 1 unit to the right of 5. So for a horizontal translation, of b units right, we want to replace x with x minus b. Notice that we have a negative here even though we're going right, which is the positive direction. And that's because we're compensating. Again, what used to happen when x equals 0 now has to happen when x equals 5. So it's our x minus b that has to be 0. That's why we have a sign change. The same thing happens with vertical translations if you are doing it right next to the variable. If you want a vertical translation of c units up, then you replace our y with y minus c, and that'll give us c units up. So let's see how that works. So I'm going to, again, replace this with f of x equals x squared. Now, if I graph f of x minus 5, it just moved the whole graph 5 units right. If I graph, however, f of x minus 3, that comes out 3 units down, not 3 units up. If we do y minus 3 equals x squared, that does move it 3 units up. But if we are doing it with the f of x, we're going to have to add it to get it to go up. So the snag with the horizontals is we have to remember to change the sign from our intuition. The snag with the vertical is that if we are working with the y directly, then we have to subtract the 3 from it to get it to move up. But most of the time we're dealing with f of x, so it's like we've put that in there, but then isolated our y again. So now we are adding 3 to the other side of the equation. And that's what we got with that f of x plus 3 right? It's because this is not an equality. We're assuming that's equal y. And that's why that's plus 3. If we had minus 3, it gets really confused because we're using the f of x and the y together. But that is our fundamental difference. So if we're dealing directly with the y's, that works. So generally speaking, y equals f of x being transformed into y equals f of, say, x minus h plus k. What letters we use don't matter. What matters is that they are parameters. Right? We're taking them from that first half of the alphabet. So this will go h units right and k units up. So let us graph. As an example, we have our y equals, or f of x equals x squared. If we let y equals f of x minus h plus k, we put these sliders in. By default, it's 1 unit right and 1 unit up. As we go to, say, 10, we are now 10 units right. Negative 10, we are 10 units left. We have that negative built in here. And we'll have similar ideas with our vertical. So we have to move that a little bit so we can see the whole range. But there we go. We can see that vertical as well. We'll play both, and we'll kind of move in this diamond pattern that we have laid out here. Let's just up the speed for our vertical translations. But these are how the transformation works. So that, in a nutshell, is our horizontal and vertical translations. Horizontal translations, we deal directly with the variable. So we have that counterintuitive sign. Vertical translations, if we deal directly with y. If we had y minus k here, and not plus k out here, then yes, it is the same thing. So here, if we have y minus, assuming that's almost 4, it's about 4 units up. But if it's on the other side of the equation, then yes, we will have that same issue that we had where we're adding instead of subtracting. So if we act directly on the y as a variable, we've got that same sign change we have with x. So the snag with horizontal is that counterintuitive sign. The snag with the vertical is we have to take a look at where it is. If it's immediately after the y, we have that counterintuitive sign. If it's been moved to the other side of the equal sign, then that sign does match our intuition. Positive k values have us above the x-axis. Negative k values have us below the x-axis. So those are the keys we need to watch for.